You guys want to hate it next year in your university, and none of your teachers know your name at all. They won't be able to pick on you at all.
At least he called me by the wrong name. Mr. Earhart, like when I had civics and careers, he called me Steven for like the first time. And Mr. Solinger thinks my name is Peter.
What a horrible name.
All right. Here we go. So I'm going to rewrite this as f of x equals sine of 3x minus 2 squared. Okay, which is okay to do. There's no issue with that. All right, Matt, I'm going to pick on you. Can you give me the first step here, please? Go ahead.
Well, you put like the 2 down in front of this, like 2 sine 3x minus 2.
Yeah.
Okay. And then when it turns to cos.
Yeah.
And then bracket 3.
Very good. Now this sort of is bugging me, this question though. Isn't there an identity that involves sine x cos x?
Nope.
Now shouldn't there be one that you guys memorized for me already that involves sine x cos x?
So you used like the whole thing, not like just the bracket?
Yeah. Because remember, it's the 2 comes down here, right? And then it's the derivative of the brackets. And then it's the derivative of this at the end there.
Oh.
It's like a chain within a chain. There is actually identity, okay? You guys are saying no, there's no identity. One of the identities is this one. Okay, so I should probably write this in a different color. Now, why might it be useful to use this identity in this case? Okay, I'll tell you, okay? Because it's very possible you might have to graph this. And it's a lot easier to graph just a plain sine function than it is a sine cos function. If I'm going to use that identity, okay, what's my x in this case? I'm just going to answer Sharon. Matt, what's my x in this case? 3x minus 2. Okay. So sine x cos x is really sine 3x minus 2 cos 3x minus 2. Okay. So I'm going to treat this as now again, this is an optional step, but I'm just putting this in here because in case we have to do something with the equation. Okay, what's that going to change the square brackets into now? It's going to change to what? Yeah, go ahead. Yeah, good. So 3 times sine of 2 bracket 3x minus 2, which is 3. This will work as well. Let's write it like that, just for completion's sake. Now, this is an example where an identity might be good. Okay, and this is one of the given ones I made you guys remember, the sine a plus b one. So that's an example where the identity might be useful for you. Okay. And does it make sense that the sine squared would change to sine? Well, I think it does. Okay, right? Because you're thinking sine, the derivative of sine would just be brought down with using the chain, right?
You can explain like everything.
Yeah, no problem. What part? Yeah, oh, I'm sorry, Joe. Are you okay up to here?
Yeah, I'm just like after the
Yeah, so okay, sorry about that. So what I said that I'm using this identity sine of 2x is equal to 2 sine x cos x. The reason for that is this is a lot easier of an expression to deal with than this is, right? So then what I did is I just rewrote it, that I put it in the form of 2 sine x cos x. So that's in the form of that. And I brought the 3 out just because we don't need that, right? That's just going to be the 2 sine x cos x. So then your x is, right, those are all, that's like your x, right? So that turns into 3 times sine 2 times that, which is sine of that. Okay. Now that's an optional step, but just what I was saying was, if you had to solve this equation, it's easier to deal with this than it is with that. That's just why I put that one in there. Yeah. Nope.
Is it purely coincidental that the derivative is the derivative of the bracket and then sign and then the exponent?
There probably is an identity for it, but the thing is, it's not always gonna work that way, because the reason it worked this way, because there was a sign change to cos, which allowed us to deal with sine cos, so it only worked for sine squared. Right, like sine cubed or cos squared, it wouldn't, because there'd be negatives and all that, right? So there's no, I wish I could say there's a magic formula to work out nicely, but there isn't. It just happens to be for sine squared, it changes, it works for them.
Where did the 3 come from? From the bracket?
Okay, just because, right here, you mean?
Yeah.
Because, well, we just did
Oh,
six,
okay,
right?
6, okay.
I just wanted to write it like this, because
Yeah.
we just getting ready to call that.
Yes.
All right, example 7, I have 2 more examples, here we go. Let's see if I can find my notes. Example 7. Oh, here we go. Oh, here we go. Oh. All right, this is the worst type. The last 2 examples are the worst ones. There's going to be nothing worser than this. Okay. So instead of giving up on this question, you are going to work your tails off. Okay. And do this question right now. Okay. Cos cubed x all over 3x minus sine x. And then when I make a mistake, you guys jump like you always do. Okay. So I'm going to say f prime of x equals 3 cos squared x times negative sine x times 3x minus sine x minus 3 minus cos x times cos cubed x. Someone confirm that for me? I think that looks good to me. Make a mistake? Am I good? Okay. Common. I'm just going to take out a common factor. I'm done. Is there anything that can be factored out? Yeah, good.
Minus sine x.
Oh, because remember the derivative of cos is negative sine, right? What I did was I did cos x cubed. Okay, right? So that's going to be 3 cos x squared. But then you got to take the derivative of this, like for chain rule. So that's negative sine x. All right, things that are common. I see a cos cubed x or cos squared x, and I see a negative. So I'm going to factor a negative cos squared x. That turns into 3 sine x. 3x minus sine x plus cos x 3 minus cos x. Is anything going to cancel after that? I don't think so. Does anything cancel? I think you could FOIL it if you want to, but I don't think you're going to get anything out of it. I don't think so. Just get in the habit of taking out a common factor, because remember you're just trying to simplify and cancel out, or that's what you're trying to do. That. Okay. Are we okay on the basic idea here for this?
So you don't want us to FOIL it ahead?
You could FOIL it for sure. The thing is, I don't think you're going to get any nice roots, so that's okay. If I were to give you a question like this and say graph or something, I'd make it that this turned out to be something nice, like 1 or x or something nice, or a nice quadratic, because to solve for that, that's what you need to teach to me. All right, last question today has involves square root, like all my different questions do. Okay. Example, can I get rid of this? Yes? Okay, example 8. It is f of x equals square root of sine x plus cos x all over x. Okay, if you can do this question, you're a master of derivatives. Okay, there's nothing I can give you worse than this. I'm not teasing, this is like the worstest one. What do English teachers think of me the way I speak in this class?